Hi everyone. In this video, we'll go through elementary operations of a matrix and also understand how to get an inverse of a matrix using these elementary operations. Elementary operations of a matrix. Basically, these are nothing but the different kinds of operations that you can perform on a single matrix. So a matrix has rows and columns, so you can perform certain operations such as interchanging rows or interchanging columns. That is nothing but you take one of the rows, say row 2 here, and put it in row 1. And you take row 1 elements and put it in row 2. So you basically interchange like this. And this is the notation for interchanging. R1 double-sided arrow with R2. This is nothing but interchanging. Similarly, you can interchange the columns. The next operation is you can multiply the elements. Say you have one row, you can multiply the elements of the entire row with some scalar number or some constant number. So say k is some scalar number, right? K is some scalar number and you have some row I. You can multiply all the elements of that particular row with any constant number. Say example, you multiply, say this row 2, you multiply the second row with 1 by 7, right? So when you multiply the second row with 1 by 7, you have minus 1 into minus 1 by 7, root 3 into 1 by 7, 1 into 1 by 7. So this is the notation. Row 2 is multiplied by 1 by 7 of row 2 itself. So this is how we denote. Similarly, you can do the scalar multiplication with columns. You can pick a column, say second column in this case. You can pick the second column and multiply with 1 by 7 with its elements itself. So this will become 2 into 1 by 7, which is 2 by 7, root 3 into 1 by 7, which is root 3 by 7. And the next operation is addition of elements of a particular row with the corresponding elements of another row multiplied by another non-zero number. Let's take an example. So say this is row 2. Here we want to take row 2 elements and subtract it with row 1 elements. That is, we want to subtract it with row 1 elements after multiplying this row 1 elements by 2. For example, say let's take row 2. Row 2 is 2, right? First element. So the matrix will be like this. You first write the matrix like this. 1 and 2 will remain the same. That is, row 1 is the same. You want to modify the row 2. You want to modify this row 2. So how would you modify? You will take row 2 elements, which is 2, right? Let's take this. Row 2 element here is 2. 2 minus 2 times of R1. 2 times of R1. 2 times of R1, which is 1. You'll have to take the corresponding elements. If you are modifying this element, you will have to take the same element in the other row, which is 1 here. So 2 minus 2 into 1, which is 0. Okay. Now we'll do the same thing for the next element. Next element in row 2 is minus 1. And you want to do minus 2 times of row 1. What is the corresponding element in row 1? It is 2. So it's going to be minus 1 minus 4, which is minus 5. So this is going to be minus 5. So this is one kind of operation. Same thing we can do with column also. Say this is C1, column 1. This is column 2. We want to modify the elements of column 2. We want to modify the elements of column 2. This column we want to modify. So what we will do? We'll take column 2 elements and subtract it with 2 times of column 1. So what will happen? Let's take first element. This is the first element of this second column. So it's going to be like this. C is equal to, you write down C1 as it is because we don't want to modify column 1. We only want to modify column 2. So what we will do? First element. What should be the first element? First element is going to be C2. That is 2. First element is 2. 2 minus 2 times of C1. 2 times of C1. What is the corresponding element in C1? It is 1. Right? And what we are going to get? 2 minus 2, which is 0. So this will become 0. Now we'll go to the second element in the column, which is minus 1. This is the second element. Minus 2 times of the corresponding element in column 1. Corresponding element in column 1 is 2. So this is going to be minus 1 minus 4, which is minus 5. So I get the second element in the column as minus 5. So what I have done, I have modified this column 2 here. So this is another kind of operation. Another topic on matrices is invertible matrices. Invertible matrices means, suppose I have a matrix A. Just let's focus on this matrix. If I multiply another matrix with this, some matrix, if I multiply with this, it should give me an identity matrix. What is an identity matrix? Matrix with diagonal elements being 1 and other elements being 0. So if I multiply matrix A with some matrix say B, I don't know what that matrix B is, but some matrix B, then I should get identity matrix as the answer. So in this case, matrix B, right? Matrix B will be called as the inverse, of matrix A. Now let's take this example. We have matrix A, we have matrix B. We multiply both these matrices. When you multiply, you see here, you notice here, you're going to get 1, 0, 0, 1. So you're getting identity matrix, which means B is the inverse matrix of A. Similarly, if we do a reverse multiplication, that is, instead of multiplying matrix A with matrix B, if you multiply matrix B with A, B into A, then also we are going to get identity matrix. So in this case, we say B is the inverse of A and also A is the inverse of B. Both are inverses of each other. So this is how we represent. B is the inverse of A. That is, A's inverse. A's inverse matrix is B and B's inverse matrix is A. B's inverse matrix is A. There are few theorems. Let's go through them one by one. Uniqueness of inverse. Uniqueness of inverse means every matrix has only one inverse matrix. Only one inverse matrix. It doesn't have multiple inverses for a matrix. Now, we'll have to prove this. So, we start with assuming that there are two inverses of matrix A. We assume. This is not true. There can be only one inverse for a matrix. But here we are assuming that there are two inverses. Say matrix B and matrix C are inverses of matrix A. So we start with this assumption. Since matrix B is an inverse of A, by its property, AB is equal to B into A is equal to I. This is the property that we just learned, right? If you need to call a matrix as inverse, then both the matrices when you multiply, the inverse matrix and the original matrix when you multiply, the result should be an identity matrix. So, since we are assuming that B is an inverse matrix of A, the property says that A into B is equal to B into A and is equal to identity matrix. The next thing we are assuming is C is also an inverse of A. Since C is also an inverse of A into C is equal to C into A is equal to I. So both these conditions should be true because they are inverses of A. Now, how do we disprove this? Basically, we'll have to disprove this, right? So how we disprove this is we start with, say, we'll take matrix B. We'll just write matrix B. Now you can write this matrix B as B into I. Because B into I, anything when you multiply with identity matrix, it's going to be that original matrix itself. It's basically like telling anything that you multiply with 1 is going to be the number itself, right? 2 into 1 is 2, 3 into 1 is 3. So anything that you multiply with 1, you're going to get the original number. Similarly, the same concept in matrices also. Anything that you multiply with identity matrix, you're going to get the matrix itself. So B is equal to B into I. We can write matrix B as B into I. Now, what is I? I is also here. I is nothing but A into C. Can we write I is equal to A into C? Because we just said that A into C is equal to C into A is equal to I. So we'll write, instead of I, we'll write A into C. Now we will just rewrite this B into A into, we'll make it like this, right? We'll group this B into A. So now, based on this first condition, right? Based on the first condition, B into A is I, right? So B into A is I. Let's substitute I for B into A, and then we are left with C. Now what is I into C? Anything that you multiply with identity matrix is going to be the matrix itself. So it's going to be C. I into C is C. And what we have on the left hand side, it's matrix B. So what happened now? Matrix B is equal to matrix C. If matrix B is equal to matrix C, that means both of these matrices are same. What does it mean? That means the inverse of A is just one matrix. Because both these matrices are same, inverse of A is only one matrix. It's unique. So we have disproved this. Thereby, the theorem states that matrix is unique. Now we'll go with another theorem. The theorem states that if you have two invertible matrices, say A is an invertible matrix, B is an invertible matrix. Invertible matrix means if there is an inverse for matrix A or if there is an inverse for matrix B, then that particular matrix is called as invertible, because you can find the inverse for that matrix, so it's invertible. Now the theorem here states that A into B, if you take inverse of A into B, it will be same as B inverse into A inverse. So here again, we will start proving this. We'll take this matrix AB, that is A into B. This has one group, and A into B, the inverse of A into B, as another group. So we know that by property, A into A inverse is I. So when you multiply matrix A with its inverse matrix, you're going to get identity matrix. Now using the same property, instead of A, we are going to write A into B. Instead of A inverse, we are going to write A into B, the whole inverse, right? Now we start with this property. Now what we are going to do, we are going to multiply A inverse on both the sides, on the left hand side and on the right hand side. We are going to multiply with A inverse, right? Now we will regroup. You have A into B here, you have A inverse here. We'll regroup this. We'll regroup into A inverse into A, because we can simplify this. What is A inverse into A? By property it is I. So we will simplify it. So we'll write it as I into B into this. Similarly, A inverse into I. Anything that you multiply with identity matrix, you're going to get the matrix itself. So what is it? It's going to be A inverse here, right? We simplified this. Now, what is I into B? I into B is B itself, right? So we get this. Now we are going to multiply B inverse on both the sides. Why we are going to multiply B inverse with both the sides is so that you can simplify. You can write B inverse into B into B as I, right? So you're going to get I here, and then we're left with I into AB inverse, and we're going to have this. Now again, anything that you multiply with I is going to be the matrix itself. That is, we're going to get A into B inverse is equal to B inverse into A inverse. So this is how we have proved the theorem. We are supposed to be proving that AB inverse is B inverse into A inverse. B inverse into A inverse. We have proved that. Just remember that it's a reverse. It's reverse. So anything that you have here should be, you should put it in reverse. B comes first and A comes second. This is a very frequently used theorem, important theorem. Let's remember this. Now, how do we find an inverse of a matrix using all of the elementary operations? What are the elementary operations that we can do? We can interchange. We can interchange rows and columns. We can multiply elements in a row with a constant number, a scalar number. We can also multiply the column elements with a constant number. Then you can add and multiply. That is, you can add the elements of one row with the elements of another row and also get it multiplied. So there are 3 operations that can be done in rows and 3 operations that you can do for columns. Clubbing all these operations, we can find inverse of a matrix. First step is, you will have to start assuming or start writing. This is the first step. Write it as A is equal to I into A. I is the identity matrix. So you write it like this. Apply all of these operations, right? You keep on applying this. It's not once, twice. You can keep on applying this as many as times until you get I is equal to BA, right? Basically, you start with matrix A here on the left hand side. You keep on applying these matrices, keep on simplifying it until instead of A, you make it I. That is, instead of matrix A, it will become an identity matrix, right? Once you get an identity matrix, then this matrix B will become the inverse of matrix A. B will become the inverse of matrix A. Now let's take multiple examples. We'll go through multiple examples, another important topic. Let's find the inverse of matrix A. This is the matrix that is given. Now you have to find the inverse of A. Inverse of A means A inverse, like this. We have to find this. What is the step 1? Step 1 is to write A is equal to I into A. So what you write? Instead of A, you put matrix A. 1, 2, 2, minus 1. You put this matrix is equal to I. What is identity matrix? For 2 by 2, 1, 0, 0, 1. Into, you leave this like this. Don't substitute the matrix. Leave it as A itself. Now, first step is done. This is step 1. Now, in step 2, we'll have to slowly go element by element in this matrix, right? And make it as identity. That means, let's take first element. What is the first element here? First element is 1. In identity matrix, we want it like this. First element is anyways 1. So don't do anything, leave it as 1. Let's go to second element. What is second element? Element 2. So you can take the row order or you can take the column order. So I'll take element 2 here. I want this element to become 0, correct? I want this to become 0. Now, if I want to make this as 0, what should I do? What operation should I do to make this 0? If I minus 2 with 2, right? 2 minus 2, if I do, I'll get 0, correct? Now, how do I get this minus 2? So, what I can do is, look at the row 1. Look at the first row. You have 1 here. If I multiply this with 2, that is, if I take it as minus 1 into 2, and this element 2, then I'm going to get 0, correct? So what I can write it as? I can write it as row 2, basically row 2 is nothing but row 2 elements minus row 1 element multiplied by 2 times. So this is my operation that I have to perform now. So when I do that, I'll get 0 here. Now what you have to do? You have to do for all the elements of row 2. You cannot just do it for one element or two element. You have to do it for all the elements in this particular row 2. So you have two elements in row 2. You have 2 and minus 1. We did it for 2. When you did it for 2, you got 0. Now for minus 1, we'll have to do. So it will be minus 1 minus. So it's going to be, let me do it here. So it's going to be minus 1 minus 2 into corresponding element in row 1. This is the corresponding element in row 1 for minus 1, which is 2. So it's going to be minus 1 minus 4, which is equal to minus 5. So we have minus 5 here, right? Now, same thing we'll have to do for right hand side also, right? Right hand side, what we have? Row 2. We have 0 here. So you get 0 minus 2 times of corresponding element in row 1. What is the corresponding element? 1. So again 0 minus 2 is minus 2. So you got minus 2. Same thing you do for second element also. What is the second element? You have 1. That is row 2 is 1 minus 2 times of R1. 2 times of R1. R1 is 0. So 1 minus 0, which is 1. So we're going to get 1 as the answer. We have done one operation now, right? With this operation, we got this element as 0. Now what next? What next? Next is, we want this element also to be 0, right? We got 1, 0. 1, 0. We got 1, 0 here. We want 0, 1 here. What do we want? We want 0 and 1 here in this column. So let's go element by element. Let's go to this element. Let's focus on this element alone. Now I want to make this element as 0. How do I make this as 0? And you have to use some other row to make this element as 0. How do you do that? The other row has minus 5 here. The corresponding element of 2 is minus 5. What I can do so that this 2 becomes 0 using this number minus 5. So there is a way, but then it's little tricky because you'll have to find some number with which when you multiply this number minus 5 should give you 2. So it's slightly tricky. So what I will do, there is a way. Simply it's going to become complex. So if you can do it, it's good. See, there is another way. What you can do is, you have to get 2 as 0. So 2 minus of minus 5 into x should give you 0. So this is going to be 2 plus 5, x is equal to 0. X is equal to minus 2 by 5. So if I do this, that is, if I take row 1, and subtract it with 2 by 5 into row 2. Not subtract, I'll have to add. So if I add row 1 is 2 plus 2 by 5 of row 2 is minus 5. This will get cancelled. And then I'll be left with 2 minus 2, which is going to be 0. So I can use this approach. I can do an operation such as row 1 plus 2 by 5th of row 2. This is a fine approach. It's a good approach. Only thing is you'll have to do this additional calculation of finding out that what that number should be that you have to multiply with another row that will give you 2 as the answer. Slightly tricky. So what I will do, I'll leave this element as is. Let me go to the next element. Find a easier way out, right? Next element is minus 5. Is there a way that I can make this minus 5 to 1? Because this has to become 1, right? For identity matrix, this corner element, the diagonal element is going to be 1. So how do I make this as 1? Simply divide by 5. If I divide 5 by 5, this is going to become 1 for me, right? So this is much simpler than finding all this extra calculations. So I'll divide this by 5. Divided by minus 5 because I want plus 1. So I will take row 2 element multiply with minus 1 by 5 with row 2 element itself. So what's going to happen is 0, you have to start with this row 2 element, right? First take 0. 0, you multiply with minus 1 by 5. What's going to happen? It's going to be 0 only. So this element is going to be 0. Then you'll take second element, minus 5, multiply with minus 1 by 5. This is going to get cancelled. Minus and minus is going to become plus. So it's going to be plus 1. So what we are going to get? We are going to get 0 and 1, right? Similarly, we have to do on the right hand side. So the right hand side matrices, we'll have to only modify the elements of row 2, right? So we'll just copy row 1 elements as it is. Row 2 elements is minus 2, row 2 elements is minus 2 and 1. We have to modify this based on this operation. So minus 2 will become minus 2 into minus 1 by 5. That is nothing but 2 by 5. Then 1 will become 1 into minus 1 by 5, which is going to be minus 1 by 5. So this is the right hand side matrix now. So we have 3 elements which are fine, 1, 0, 1. Now this is the element that we are left with. This has to become 0. If this has to become 0, then you have to perform some operation by which this becomes 0. Now, I should take another row element to make this 0. So you have this row 0 and 1. If I multiply this 1 into 2 and minus with this 2, then it's going to become 0, correct? So if I take row 1 element, subtract with 2 times of row 2 element, then it's going to be 0. So let's take that example. So we are going to modify first row here. So leave it like that. Second row, we are going to just copy. Second row is 0, 1. We don't want to modify second row. We are going to only modify first row. So in first row, 1 minus, it's going to be 1 minus 2 times of R2. 2 times of 0 is 0. So 1 minus 0 is going to become 1. Then next element 2. 2 minus 2 times of R2. 2 times of R2. That is 2 times of 1. So it's going to be 2 minus 2. This is going to go 0. So what did we get? 1, 0, 0, 1. So all the elements have been obtained the way we want. Now an identity matrix is formed. Right? And same thing. Let's not forget. We'll have to do the same thing on the right hand side itself. Right? On the right hand side, it was 1, 0, 2 fifth and minus 1, 5. So we'll copy the same thing here, 2 by 5, because we only want to modify first row, not the second row. First row we have 1. 1 minus 2 times of R2. 2 times of R2. R2 is 2 by 5. Right? So it's going to be 1 minus 4 by 5. 1 minus 4 by 5, which is 1 by 5. So we got 1 by 5. Similarly, second element is 0. 0 minus 2 times of row 2. What is row 2? Minus 1 by 5 into 2 times. So it's going to be 0 plus 2 by 5. 0 plus 2 by 5, which is nothing but 2 by 5 itself. This is our right hand side matrix. This is our identity matrix. Now we have come to final step, step 3. So we will stop when we get this identity matrix. I is equal to, we have A as it is. Now we will name this as B. You don't have to name it. For now we'll name this matrix as B. So we got I is equal to B into A. This B is nothing but A inverse for us now. This B is nothing but A inverse. So A inverse is equal to this matrix. This matrix is our A inverse. A inverse. So one thing, right, when you're doing this operation, there is no particular order in which you have to, address each element. But it's better to follow one order. You can follow any order. You can make this as 1, you can make this as 0, this as 0. Any order. First you can take this as 0, then take this one, take this one. Any element in the matrix you can take and try to make it as 0 or 1, right? But it is better to have one pattern. So pattern is probably you take first element, second element, third element, fourth element. Go like this in an order. Take first column, make it close to identity matrix. Take second column elements, then take third column elements. So go step by step just to make it little structured, right? And sometimes following that pattern also eases the problem a lot. Here, see, in this case, I've changed the sequence. In the first case, I made 2 as 0 here. But here I'm making this 2 as 0. Even if you do that sequence, you will get the same answer. Same answer you will get. And we did using row operations. We can do the same thing using column operations also, right? When I say column operations, you can take column 1 elements and add it up with another column's elements. Like this. See here, column 1 elements multiply by 1 by 5th of the same column 1 elements. See, all these operations you can do using column method also, whichever is comfortable. So there is one key note that we'll have to remember. If while doing these operations, right, if we find a particular row having all elements as zeros, or if you have one particular column with all elements as zeros, you will have to stop it there. This will indicate that that matrix doesn't have an inverse matrix. It's not necessary that every matrix will have an inverse matrix, right? Some matrices, if you see that the entire row is having zeros or entire column is having zeros, then that means that particular matrix doesn't have inverse matrix, or that matrix is not an invertible matrix. Now, this is a case where inverse does not exist. So this example, this is the matrix. In this matrix, let's take this step, right? First step is P is equal to, this matrix is named as P. So P is equal to I into P. This is always you have to follow this step. Very important step, right? Very important step. Now, you write substitute matrix P is equal to I, identity matrix, and leave this P as it is, right? Now, you take the first element. We'll go step by step. First element is 10. You can make this 10 as 1 because it has to become 1. 10 as 1. How can you make 10 as 1? Simply divide 10 by 10. It's going to become 1. So take the same row itself, 1 multiplied by 1 by 10. So it's going to be like this, right? It is 10 minus 2 minus 1 by 1 is equal to, this is the matrix. I'll multiply this entire row with 1 by 10 so that I get 1 here. So I'll get 10 by 10 is 1 minus 2 by 10 is minus 1 by 5. This is the matrix I get. And I leave this row like that. I'll leave this row because I'm not going to modify row 2. Now, I'll come to the right hand side. I have to multiply here also by 1 by 10. So 1 into 1 by 10 is 1 by 10. 0 into 1 by 10 is 0. And this is 0 and 1. Now, so this is done. Now, I'll make this, I want to make this minus 5 as 0. Right? I want to make minus 5 as 0. How can I do this? If I multiply this 5, if I multiply this row 1 element 1 with 5, it's going to become 5. And when I add this, it's going to become 0. 5 minus 5 is going to be 0. That means what operation I have to perform? I have to take row 2 elements because you want to modify row 2 now. So I'll take row 2 element, right? Row 2 element, and I will add it to row 1 element after multiplying. That is 5 times of row 1. 5 times of row 1 is 5. And I have minus 5 here as row 2 element. So row 2 is going to become minus 5 plus 5, which is 0. This is what we want. So we'll get 0 here. We'll have to do the same thing for this element also. So we have 1 here. So row 2, 1 plus 5 times of R1, right? Plus 5 times of R1. R1 is minus 1 by 5. So you will get this and this will get cancelled. So you'll have 1 minus 1, which is 0. So we got 0. So we got 0 here. 0 and 0, right? Here, the row, we got both the zeros. Since we got both the zeros, we'll have to stop it here and say, since second row has all zeros, inverse does not exist. Inverse does not exist. So with this, we have come to the end of this particular topic. Hope this video was useful. Thanks for watching.